Hello friends, this is Shubham and welcome to my YouTube channel. So today in this video, we'll talk about image augmentation, like what it is and why it is needed, what procedures or methods or pipelines do we follow to achieve image augmentation. So let's start with what image augmentation actually is. So basically it is a technique of altering the existing data to create some more data for the model training process, and this is particularly done for deep learning use case because like there are different models like for images like CNN, right? So we build image classifiers or anything. So before that we have to do image augmentation. And why do we do image augmentation? So as you can see in the screen, one single image has been upsampled and augmented, like using various transformations, and now this can be used by us to train a deep learning model. Okay, so a single image has been transformed, and how these transformations are happening, we will talk about this in this like later part of this video. And for that, so what we are doing particularly, we are artificially expanding the available data set, right? We have available data set, say we have three images. Out of from three images we are creating so many things, right? We are just artificially or synthetically expanding the available data set for training purposes, like for training a deep learning model. Okay, so this helps in increasing the training sample and without going out or collecting the data. So you don't have to collect the data, you just apply image augmentation on your like a smaller data set, and you can create a larger data set like this. And you, as you know, that more the data and better the quality, better will be the deep learning models performance. So let's dive into this and check out how we can achieve this, and particularly talking about a library called imgaug, using which you can create sequences, right? You like you do in keras for building deep learning models. You create a sequential model, and then you create CNN model or LSTM model, anything. So same here, as a imgaug library allows us to do similar thing. Like these are the meta augmenters. I'll talk about what is meta augmenters and all. So this is a sequential thing. You can see you can create a sequence, like all the images will go through this sequence and will be stored in your say a folder. Okay, so we are applying augmenters like cropping the image, flipping the image. This is a flip left right. There is another flip called flip up down. Okay, so Gaussian blur. Okay, so this is just a standard use case. Or for better performance, you can use, say, a simple and common augmentation sequence. So this is a common augmentation sequence that we use. Okay, so flip, then crop, then sometimes. What is sometimes? I'll talk about this. What is Gaussian blur? What is linear contrast? Then what is additive Gaussian noise? You're adding some noise to it. Then what are the affine transformations that you're applying, like scaling, like translation, then rotation, shear. Okay, so these are the things that you apply to this. And after applying, as you can see in the image, a single image has been transformed into beautifully like a, you are expanding the images, right? So how, so let's walk through the code, and let me show you an example. Okay, so this is the code that I have written, and this is what I have done. This is just a copy paste of this. Okay, this is the I've taken the code from here, and as you can see that first I am just loading the libraries, ignoring the warnings, choose the like the directory path where my image has been kept. And then this part is for, like, we are allowing only PNG and JPG images, okay, of that format. So this is nothing. Let's go down and just this is what we are doing. Like, if it is not like we are just changing it to BGR to RGB and all. So after doing this, this is the part which I'm talking about, and this is the IAA that has been imported here from imgaug import augmenters at IAA. Okay, so same thing we're doing here: sequential flip, crop, sometimes Gaussian blur. Or you have to follow this entire pipeline. Okay, so I have given a link to each to understand each of these here. See, let's go to the sequential, okay, and understand what it actually is. Okay, so let's copy and paste it here. Just paste it and you can understand what these are actually used for. So sequentially is comes under a meta tag here. Okay, and inside that you give the children augmenters. Okay, the child augmenters. The child augmenters are like this. You are giving this, right? You're writing these child augmenters inside the sequential meta tag. So inside these are called child augmenters. Like similarly, this is also comes under a meta tag only sometimes. Okay, this is also a meta tag. Inside this you are using this child augmenter called Gaussian blur. You can see here if you go to meta, you can see augmented, then sequential is a meta tag, meta augmenter, then you can go to sometimes, sum of, all, like sum of and one of, and there are many of them. So you can get all the augmenters here, like whatever operations that you want to perform on your images, you can get it here. Like pooling, if you want to perform, then you can go to this tab and you can check out all the pooling, like average pooling, max pooling. If you have done deep learning projects, then you will know what average pooling and max pooling and all these things are. And after pooling, then you can just check it out. Okay, like if you go to this code, and I'll give you this code in the GitHub and share the link with you, and you can see what sometimes is like. It is like 50% of the times you're applying this Gaussian blur to your images. Okay, like 50% of the times. So if you go to this sometimes, if you, okay, you can go to directly from here and meta tag, and here you can go to sometimes. Okay, so here you can see that child augmenters, like Gaussian blur was there in my, and you have to apply the child augmenters with the probability of p. So here the probability I have given is 0.5, like 50% of the times you can apply the Gaussian blur to your images. Similarly, this is a contrast normalization. What is normalization? If you have studied machine learning, you will know what normalization is. Just this is just to you are applying the normalization similarly on your contrast, is just to strengthen or weaken the contrast in each image. Okay, then these are the some values. You have to know the range, and for knowing the range you have to follow this documentation. Okay, so similarly, this is the additive Gaussian noise. You will get everything in this documentation. Multiply, okay, multiply is a very good operator. This is actually used for lightness, like how dark you want to darken your image, you want to lighten your image, you can use this. Just go to this link. I'm going to show you how useful it is. Let me show you here. Okay, so here you can get the multiply. This augmenter can be used to make images lighter and darker. This is actually very much important because while training your deep learning model, you want to play with the contrast, play with the brightness and everything, so that your deep learning model is trained better. Even if you are uploading your hazy images, so that it can actually classify, like understand your images, find out the edges and whatever you want to perform on the images, right? So if you want to perform deep learning tasks and anything, so actually your this image augmentation is very important. So similarly, this is the affine transformation. Here you can just go to this link and you can find out what affine transformation is and what are the different procedures and what are the different things that you can do through this. See, here it is: translation, rotation, scaling, shear. Okay, so all these you can get it here, why it is used and how it is used, what is the range of each values that you want to put. Okay, see here I put the 0.8, 1.2. So what are these x-axis, y-axis, and how much you want to scale in each axis, how much you want to translate in each axis, how much percentage, how much rotation you want to do, then how much shear. Okay, then like similarly you have to just look through this documentation. Okay, so what we are doing next is we are doing augmentation 8 times. Say you have got like you have got one image. Okay, then you, after augmentation, it will become 8 images. Okay, so 8 into 1. So if you have got say 11 images, then it would become 88 images after augmentation. Okay, so what you're doing is just doing a loop and doing applying the sequence. Okay, here is the sequence, you can see applying the sequence and then just writing it to our folder. So I will show you the folder here. Here I've got this file. Okay, here is the image and I've got image of a cashew. As you can see, I will be deleting all this for now, and you can see the original image here. Okay, this is the original image we have. So let's run this program, and let me open this and Python multiply. Yes, just run it. Wait for a few seconds and it will give you all the results. Here you can see here populating all the results. Yeah, so you can see all the images have been populated, and you can go through this. Just look at this original image and others. Just see, this is some flip, rotation, translation that has been happened on this one. Okay, so yeah, you can do this. And moreover thing, you can see that nothing has been flipped here. So you, to completely flip, you can use 1.0 here. Okay, then I will show you how it is done. And let's go to this folder, delete this. Okay, it depends on a use case. If you have got some names that you want to classify, then don't use this, don't invert it because it's not needed. Okay, and if you have got images like cashew, then you can always invert it, like to get the view from all angles. So here you can go and just run this. Okay, just wait few for seconds. Yeah, it is done, and you can see the original image here. Okay, and then I will show you. Let's just yeah, and I can show you this. Okay, wait, this has been, see, this has been translated as well as rotated. Okay, it has been flipped. Just look at this, Just look at this one. Okay, so similarly, with one image you have created, see, 8 images. Similarly, if you do like 10 or whatever your use case would need, you can just play with this file, and you can generate your images as you want. So that's all for this video. And in my previous video I have built a lentil and nut image classification system, where I've told you, like, if you're a bachelor, if you're living alone and you have to cook every day, so you have to know the what type of lentil, because in India mostly lentils or dal, which we call here, is staple food here. So to know about it is very important, and you should know what you're cooking, right? So lentil and nut image classification model has been discussed in my previous video, how we have built that. Like, I've just given a demo, and image augmentation was a part of it, so I have covered it in this video as well. So I'll give that a link to the previous video in the description of this video. Do check that out before watching this one. And in my next video I will do the code walkthrough of the entire project. So just stay tuned, enjoy the content, and see you in the next video. Bye bye.